Okay. Okay, so in the last class, we discussed the two major important steps. One was the charging, and another one was the exposure. So now we are going to discuss the next important thing, which is called development. Okay. Now, developing the photoconductive drum or photoreceptor is something like this. So, as of now, if I consider the thing like we have already sensitized and exposed. So, currently my plate is having a charge distribution like this. That means, in a very simple way, we can think that wherever I want to print, I have the charges over there. So this way, this charge pattern is basically representing my image that I want to print, or what I am going to print, that is now been represented in terms of charge. So that is why this particular image, which is made of charge, is called latent image. That means you can't see it, but it is there in terms of the charges. So development or the developing the plate basically tells that you put the colorant onto this charges. Okay. So what is the fundament? What is the easiest way to do that? That you can introduce toner particles, basically the powdered colorant over here. And as you can understand, as in the first day also we discussed that once you introduce them, then uh, they are also charged. Okay, they are also charged in the opposite polarity. So if they are negatively charged, so they are going to get attracted by these charges and they are going to get deposited over there. So you get, instead of this charge, you get the entire image. Now after development, you get this image. Instead of charge, you get the same thing in terms of the colorant or toner. So after development, this is what you get. So after development, you get, instead of charges, you get a visible or a printable image over there, which is called the developed image. So this is what fundamentally development does. Now, as you can understand, there are two important things. One is how we give this toner particle charge in the opposite polarity of the charge deposition. And there is another very important thing. Now, you see, there is one thing very important over here that we need to understand a bit. And this actually requires a secondary element which is sometimes very important. But before that, we need to understand the problem. So think that this is the plate you have. Okay, this is the photoconductive plate, and what you have, you have the charges over there. Now if you think, in a bit detailed way, you can understand that why these charges are actually means resting in this place, why these charges are actually attached to this plate. One reason is you have the opposite polarity of charges over here. Okay, that's why they are actually attached over this particular location as per the exposure. Now, if you have a charge construction like this, you can get into another problem. See, in these areas, in the edge or border areas, what happens? You can understand that this potential difference of the negative charges are much higher compared to here, because you have a very good concentration of charge over here. But here you can see that the negative charges are having more power, you can say, in this particular locations. That means majorly in the edges. Okay. So this sometimes causes a big problem. What is the problem? That in this end, in this edges, these charges tries to get neutralized. Okay. So what is the result? Say for example, you have something to print like this. This is what you want to print. And for that, just you can think that okay, I need a charge distribution like this. But because of this reason, what happens? Instead of this, you get a charge distribution of this nature. That means at the output, instead of this kind of thing at the output, you get something like this. Because at the edges, you lose the charges. Okay. So this particular effect is called fringing field effect. And due to this fringing field effect, the result becomes, means the dot, if you think, if you want a dot of this nature, instead of this you end up getting a dot of this nature. Yes, you get something like this. Okay. So this is something we also call, this is a halo effect. Okay, people who are from RIPT, they may know that this is also called something as an halo effect. Okay, this halo effect, what is the final output? The in the effect we get that instead of a solid black or solid ink, what we get a faded kind of appearance at the edges. Okay, so the edges are not very clear. And fringing field effect, what I already told, that is the reason why this happens. Okay. So to avoid that, we have a very important element in xerography and electrophotography, which is called development electrode. Okay. These development electrodes, what happens? They get introduced above this. Okay, that means something like this. Okay, and they are actually in the same polarity as your base material is having. So they are basically connected to this. Okay. So if it is connected like this, then what is going to happen? You are also getting a negative potential over here. Now this is having a very big advantage. The main advantage is, as you can understand, now when you introduce these toners over here, which are also negatively charged, they not only get an force of attraction towards this, but they also get a repelling force from this development electrode. So it is having two attraction now, sorry, two force. One is this attraction, and you also have a repelling force, and that actually force this toners or this colorant to go and attach over here. And why this thing is avoided, because these negative things, they actually again get a repelling force from this place. So that's why it helps to maintain these edges, the positive polarity that is already over there, that helps to maintain that in intact. Okay, so that is why this development electrode is having a very important role, that it helps to maintain the intensity of, or you can say intensity or density of toners uniformly. That means across the thing. So you are at the, because of this thing, you are going to get something like this instead of this. But if you don't use this development electrode, then you may end up with this halo effect instead of this solid ink effect. Okay, and development electrode has other helps also. One of the major, it is used, it is many of the times used as reversible development. Okay, that means in there may be cases where you want these areas which has got exposed, that to be printed. Okay, so in those cases also, like you can have something like using this development electrode, you can achieve that. There are other ways also, but using development electrode also you can do that. Okay, there is another advantage of development electrode, that you can also modulate the intensity or the density. That means, as you can easily understand, that here if you change the potential, say for example, if you put a higher negative potential over here, then what is going to happen, more toners are going to get forced to this location. And if you use a lower potential difference over here, then what is going to happen, although this charge is uniform, but less number of toners are going to get attracted over here. So at the output you are going to get a deeper region, and here you are going to get a lighter region. Okay, so this way you can also modulate the printing. Actually, this development electrode is a mandatory thing if you are going to produce something of an half tone. That means not a continuous, not a line tone. That means the entire thing is not of the same intensity. There is variation of intensity. Somewhere it is dark, somewhere it is light. In those kind of cases, we use a technique called half tone. I think some of you may be aware of this. Anyway, I'm going to talk about it afterwards when we are going to talk about the prepress part. But for half tone production, uh, this development electrode is a fundamental thing. This is a obvious thing which is used. Okay, so this is the importance of development electrode. Now, one thing beforehand we should say, that in many of the cases development electrode may not be present in the way that we have shown here. It may be in some other way present in the development arrangement. Now coming to the process of developments, there are many processes. Some of them are in R&D level, some of them are in actual implementation level. So I'm going to list down, and then I'm going to discuss few of them, but I will give you the handout where I think some more will be present. I am going to list down some of the basic development process of electrophotography or xerography. And one more thing, I'm also, you please remember, I may be continuously telling electrophotography and xerography, but I may not be that frequently repeating the word laser printing. But please keep in mind that laser printing principle is same as this. Okay, as in the previous days discussion, we already told that there we don't use any, normally we don't use any light emitting sources like a bulb or lamp, all these things. Rather we use a laser which is emitted by a laser diode to expose the photoreceptive drum, and that is why we call it a laser printer. But principally the working principles are same. Okay, now I am just going to list it down, few of them. The first one which was used historically, it called cascade development. Then we also have uh, far brush development. Then we have magnetic brush development. Then we have impression development. Then we have called something called powder cloud development. Then we also have one thing called selective toner development. And there are many other, but also we have one thing very important which is called reversible development. And there are others also, but these are some of the very few which are very commonly used and they are actually used in the machines. Among them, these three are principally same. Okay. So we will start with these three. They are, as I already told, they are principally same, but they have different materials, and according to the use of materials, they have been named like that. As you can understand that in far brush we use a far material, in magnetic brush we use a ferromagnetic material, but anyway the principle is derived from cascade development. Okay, so let us see what is the principle of cascade development. Before we go to cascade development, we have another concept to understand, which basically a static electricity thing. It is a parameter of static electricity, which is called triboelectricity. Do you have any idea what is meant by triboelectricity?
No, sir.
Okay, triboelectricity is something like it is a concept of static electricity, that if you have two similar objects in contact, okay, then they actually keep in contact because of the static electricity, and the particular means the principle, or this particular phenomenon is called triboelectricity, because one object will get a negative polarity and another one will get a positive polarity. Okay, you can just think of, it is not exactly the case, but you can just think of, if you go to any seaside or any sea beach, you will find that there are a bit small stones are there. Okay, sandstones kind of thing, and you will never find a stone without the small sand particles on it. Okay, you will always see like this. Okay, this is the thing actually, because why they are attached, one reason is this triboelectricity. Okay, because one is having a negative polarity and one is having a positive polarity. However, the amount of the potential is very small, that's why you don't get a shock or anything, but this is what actually happens. Now the question is, which one is going to get positive, which one is going to get negative. Like many of the things in chemistry, here also we have a triboelectricity table or chart. Now in this table, if the material is having higher position, then it will get positively charged. If it is in lower position, it will get negatively charged. So if say A, B, two materials are there and they are actually attached by this triboelectricity, that means A will get positively charged and B is having a negative charge. Okay. Now this thing actually used for this development process, but this process may be not happen very naturally. You need a simulate, you need a catalytic action to achieve this, and majorly that is nothing but friction. Because if you can remember, in our school days we used to do an experiment that we used to take a comb, we used to rub it on a, on a blanket kind of thing, and then if we put on the papers, we used to see the papers are getting attracted, and we were taught that this is happening because of static electricity. So here also we need a stimuli to do that. So what we basically do in case of cascade development, what we do, uh, let me first draw. So basically here we have a, you can say a tray kind of thing, and in this tray we have this dissimilar particles, okay, like this, which are bigger, and then we also have the toners. So I am drawing the toners in other colors so that we can understand. So toners are the powdered particle which are of very, like some micro nano size. So these are the toners. Now if we rock this thing, that means if we just make a rocking of this tray, say if we just like one sec, just I can't show it here. So if I just rock it like this, that means this way, if I just uh, rock it, then what is going to happen? A good amount of friction is going to work in between them. And normally these small elements which I have told, these are called beads. Okay, and they are basically some polymeric material. Majorly it is made of polyamide, but anyway it can be of other stuffs also. It again depends on what is the toner particle we are using. So when this type of rocking action happens, this is called a rocking action happens, then due to this triboelectricity, after this action, these small toners, they get attached to the beads. So we have a a thing like this, where this is the bead and these are the toners. And as per the triboelectricity, the beads are positively charged and these toners are negatively charged. Now you think of your plate. I am just drawing the this thing, the photoconductive layer. I may not be drawing the base. So now this is the plate you have. Okay. And in this case, what is going to happen now when you introduce this bead mix toners over here? So basically, you are having the structures like this. Here also they will be here because we are not putting it selectively. We are just flooding this area with this uh, bead and toner, this mixture. Okay, and as you can see here how it is, these beads are positively charged and these toners are negatively charged. So this is positive charge, so that's why they are attached to it. But remember, this is just a static electricity, so the potential is very less over here. So when they are subjected to this vicinity, what is going to happen, since this is having much higher potential than the beads, so these negative charges are going to leave these beads and they are going to come and they are going to get attached to these positive charges to neutralize. Okay, and what happened to the beads? The beads, as you know, there means after these negative charges are gone, they don't have any charges to get attached to. So we have different ways to collect, and this is another use of development electrode, that where you can take, sorry, you can introduce a collector bar over here which is having negative charges. After this it should be on, it should not be on beforehand. Okay, so that then what will happen, that with the toners itself they will go and attach to this. Okay, but once this is done, then for the beads what can be, like, if this is a negatively charged electrode, then these beads are going to get collected over here and they are going to again used for this. Okay, beads are like toners, once used then they won't be used anymore, but beads after using they will be again brought back over here to mix for the next print. Okay, so that is how the cascade development works. Is it okay? Have you understood how it is working? Any doubts?
Sir, it is okay, but I
Yes,
have an doubt. Can I ask you?
Please, please, please.
Sir, what the development electrode you have told, there you have told also the reversible development. Can you explain it again?
Okay, I will tell that afterwards. That is a separate topic altogether. As I told, that development electrode is used, can be used for reversible development. That I only told. I have not told how. That I will tell afterwards. Let me finish this fundamental development processes, then I will tell that. Or rather, you can also think that how it is possible. It is very easy. As I am telling, the only thing here means principle. To understand the principle and theory, the only thing you have to think, that what should be the charge dynamics. If I want the negative charges to go to these areas, then what charges should I put to force it? That is what you have to understand. Nothing else is there. So you can also think of it. Okay, anyway, I will tell you, I will give you the required notes, everything is there, but try to think yourself. Okay, anyway, other, any other questions, any other doubts?
No, sir.
Okay, now coming to the far brush development, and this is the same way it is, but only thing, what we use instead of this cascade, what we use here, we use here a far brush. Now what is this far brush? Far, from the name, as you can understand, that this is a brush like this which is having a far material. Okay, this is a far kind of material, and these materials, when they are put in the toner tank, or you can say the toner tray, then again due to this triboelectricity, these toners they get attached to this far brush. The fars, that individual fars, they actually means the toners get attached to this fars. Okay, so basically after this process, what happens? You get a like this, and with this you have the toners attached to them because of the triboelectricity. Because FAR, the material FAR which is used, it is having a higher position in this triboelectricity table. So then what is going to happen? Then the same process, then the same process that you are going to, something like a painting, that you are going to paint this charged thing with this brush. Okay, so the moment you are going to brush on this particular surface, again the same thing is going to happen. This negatively charged toners are getting attracted over here, and when it comes over here, none of the toners get attracted, so they remain with this far. So here one advantage is you don't have to do that big recycling things. That means you no need to collect the beads again, and then again you have to put back over there. Okay. So that is one of the advantage. But anyway, this far brush is not much used nowadays, because these fars which are created, like they were from the fur of some of the animals. Okay. So due to some environmental issues and different issues, this is now not used. It is not used to. It is not allowed to use, rather. Okay. So the next process, which is used in most commonly in case of economic range of electrophotography machines and xerography, not the xerographies that you are seeing today in the digital xerographies, but earlier how the xerographies were happening. In those cases, this is most commonly used. That is called a magnetic brush development. And this magnetic brush are basically made of the ferromagnetic materials, where we had a magnetic core like this. Okay. And here what is going to happen, these toners are basically mixed with, this is the toners, and these are actually mixed with ferromagnetic materials, which are a bit bigger in size, and they are also having a higher position in the triboelectricity tables. And this is called a magnetic core. And this magnetic core, it is having, when you bring it over here, then due to obvious reason, due to the magnetic field, what is going to happen, this ferromagnetic material, along with the attached toners to it, they go and get attached to this magnetic core. So what happens after this thing, this core takes a shape something like this, a chain kind of formation with the ferromagnetic material. And with this ferromagnetic materials, you have this toners, they are attached to this material due to triboelectricity. So actually here we have two fields over here. One is the static electricity and another one is the magnetic. Actually speaking, we have another field also, because these magnets are basically electromagnets. Okay. Otherwise, what will happen, you cannot detach these iron beads or the iron materials from this. So once the development is done, since this is an electromagnet, then we can detach this ferromagnetic substrate from this magnetic core, and again we can mix them with the toners. So we can have a repeated development. Okay. Now once this chain like thing is done, the next process is same as this far brush development, that you are going to paint this plate with this brush. So wherever we have positive charges, they will attach the toners, rest will not get, the toners won't get deposited over here, So you get the developed thing. Okay, so cascade development, fire brush development, and magnetic brush development, they are actually the same process. Only thing, they have a different arrangement of beads, of ferromagnetic substrate, and all these things. Okay, till here it is clear to you.
Yes, sir.
Okay. The next thing is impression development, which is basically used for nowadays the digital Xerox machines, and this is almost like a impression cylinder printing kind of thing. Okay, so let me first draw it so that it is easier to understand. And this in the impression development, like we don't have a plate kind of arrangement, we have a cylinder arrangement. Okay, one sec, just let me just draw it first. Okay, because it
Sir, you are not audible.
I'm not talking. I'm drawing. 1 second.
Oh,
Okay, more or less, this is how the picture is. Like it is maybe somewhere it's not very well scaled and all, but you can. I hope you can understand how it is working. That you have a toner supply or a tray with toner, and you have a metering roller, and as you can see that this is a gear kind of thing. Okay, and the pitch of this gear, that means what is the gap between two teeth, and that actually determines that in every rotation how much toner is going to get dispatched from this tray to system. It comes on this roller which is called a mohair roller. However, this mohair material is no more used because of the same reason, that mohair is a material, normally it is taken from some of the goats and all. Okay, but nowadays we don't use mohair, we use a synthetic material, but the name remains as mohair roller. Okay, then again we have a velvet roller kind of thing over here. Now this mohair roller, it is having a lower, triboelectricity rank than this velvet. So that's why the toners move from this to this. Now you will tell then what is the reason of this. It is having two reasons. As you can understand that it also works as a transfer roller or transmission roller. And again, you have to understand one thing, that if you keep this powdered material for a long time in a tray or something, you can get that you can, many of the times you will see that they get agglomerate. They actually join together, right? So this kind of action also make them free, make them much more free flowing, because your toners, if they are clustered, if they are clubbed together, then suppose you wanted two toners to produce a thickness like this, but instead of this, instead of 2, you got this much toners over there, so you will have a very dark output over there. You cannot get a quality output. Okay, so this also helps to remove such agglomeration, some cluster in the toner, and then from here it get transferred on this photoconductive drum, and you can see that this is a one go process because of this cylinder. Okay, now here you can see that when it comes over here it get charged, then it get exposure, and then when it moves it gets the toner, it gets developed basically, and then when it comes over here the substrate moves in between, again we have another support roller over here, and then that transferred to the substrate. Now here we have a very important thing, that these two, this this is important to remember. Basically these two are metal cores, okay, and these two metal cores are actually connected, and the potential difference over here, this basically works as the development electrode, because you can understand that if you have a higher potential difference, more toners will move from here to paper. If you want a lighter one, then you can have a lower potential difference, and this is one of the fundamental way what is employed in case of commercial digital Xerox machines, because the many of the times you tell no that okay এটা একটুখানি dark করে দিন, এটা একটু light করে দিন, so basically you will see they may be pressing some buttons and all. Now what it is actually doing, it is the control system which actually changes the potential over here. Okay, now according to the potential changes, the transfer happens. If you have a higher potential difference, you will get a deeper thing at the output, and in the other case you will get a much thinner, a much lighter at the output. Okay, so this is what is called impression development. The last one for the day, the reversal one, I am not going to tell now because I am as I think Pinky asked me, I am not only Pinky, I am asking you guys also to think once, how can you use this development electrode to achieve the reversal printing. Just think of yourself, it is very easy to understand, just try to think a bit. So I am going to end with the selective toner development. Okay, no, that also I'm not going to do. I can, okay, let me do two more is important, so they won't take much time to understand. Let me just start it with the selective toner development. Now as the name says that here what is going to happen, here we are not giving the toners only to the places where the charges are remaining. So here the toners are given selectively. So how it is achieved, basically it is the same process, but in this case what happens, the exposure happens after the deposition of toners. Instead of previously exposing and then putting toners, here the process is a bit reverse way, that first we this is the photoconductive thing, but here there is one difference in selective toner, that we don't use a metal base over here. Okay, we generally use a fiber base over here, because if you see the process, you need this thing should be transparent. Okay, so this is the photoconductor, and on this we have the charges across the photoconductor, the same charging process, and then the toners are getting attached onto it, irrespective of where it is required, where it is not required. Okay, these all are getting attached to the oppositely charged toners. Now what is going to happen? Now the exposure is given. Okay, suppose the exposure is given in these two regions, and as I told that in this case the exposure is basically getting passed from this material. Okay, now wherever the exposure comes, these toners actually get the charges in those locations. Okay, as I told previously that the photons that are there, that actually ionize them. Okay, and then what is going to happen? Then again, when we put a brush on this, so as these charges are neutralized, because you have already given this uh, exposure to neutralize the charges over here. However, these toners where you have not exposed, they are actually attached to the plate. But these toners where you have exposed, the toners are basically neutralized. So when you pass them, then what is going to happen? Your this thing, like which are neutralized comparatively, they get attached to them because of the triboelectricity. So after this you get these places no toners wherever you have put exposure, and then in these places where you don't have exposure you can use this. So it is just the same as the conventional process, but the only difference is here we are, according to the exposure, we are keeping toners some places and we are not keeping toners in some places. That's why we call it a selective toner development. However, in this case also you can have a reversal development. You can easily understand that we can also make this brush in a polarity so that the toners which are attached to these positive charges, they get attached, and which are neutral, they remain over there. So you can also get a reversal development using this technique. However, I am also I must mention that this is a yet to be very much used in the commercially practiced things, but in terms of R&D, in terms of research, this has been invented. Okay. Now the last thing for today, I know I'm taking maybe few minutes more, but I have to finish this, so just give me few minutes more. So this is called a, sorry, this is called a last thing for the day. This is a powder cloud development. So again, the same thing over here. You have the plate and you have the exposed plate over here. And here what happens, here we have a jet kind of arrangement. That means we have the toners over here. Okay, and these toners are basically jetted in this vicinity in a very high speed. That's why this powder make a clouds kind of arrangement over here. Okay, clouds kind of arrangement over here. That's why it's called a powder cloud development process. Now what happens here, there are two things. One is because of this high speed, they get a very huge amount of friction in this orifice over here. Okay, and due to this friction and the material used for this nozzle, they actually get negatively charged. Okay, the electrostatic charge, again that triboelectricity. So once this negatively charged toner mist come over here, they get attracted by them and then they get attached to this. And once this is done, once they get attached over here, then again the same thing, that development electrode come into picture, and that is also at the same potential as this, because the reason is this electron, this electrode, the development electrode here, the purpose is more than this uniformity here, the purpose is it works as a collector, it works as a collector. That means that whichever toners have not been used, they are going to get collected by this development electrode. Okay, so because these negative toners, they don't have any place to go, so they will go and they will get attached to this place. Okay, but here one advantage is that there, that the development electrode is having a very low potential. So even if you know, even if you put them, now what is going to happen if it is having a positive polarity but the potential is very low and this is comparatively high, so obviously the toners are going to get attracted over here, and these toners, as they don't, they are negatively charged, and here also we have the negative charge, so these toners, they get an attraction force by this development electrode and a negative repelling from them. So both of them help them to reach this one, this development electrode, and then they are collected and they are again used back over here so that they can be again put into the printing process. However, all this is also not very much commercially used, but they are having a very good research scopes over here. And one more thing, despite of so many electrode and so many arrangement, it is very obvious in Xerox particularly, which is much less nowadays in electronic Xerox system or digital Xerox system, that you will always find there are few toner particles which get attached to this non-image areas, and that's why it is very rare that we find a Xerox copy without any unwanted black spots. That's all for the day. If you have any doubt, I am taking another 2-3 minutes. Please do let me know.